Hello, in this recording, I wish to go over some more examples involving inverse trig functions and other functions, which when we try to find a derivative, we will apply the chain rule. All right. The first example I'd like to go over is y equals to arctangent of x squared. All right. So we're going to differentiate. Obviously, this is not implicit function, even though we could treat it as implicit function. Okay, so let's first derive directly. So we take a derivative with respect to x on y. And this will be equals to, right? We're going to apply chain rule. And y will be replaced by arctangent x squared. And applying chain rule, we're going to have derivative with respect to u, right? So we have tangent, arctangent u. And of course, obviously, u is x squared. And then we do du dx. And the, excuse me, the derivative of arctangent is 1 over 1 plus u squared. Okay, so here you may like to note, or it's not really necessary, but it's for future reference, right? And du dx is going to be the derivative of x squared. So derivative of x squared. And that's going to be 2x. Simplify and substitute u squared by in terms of x. So we're going to have x squared and then squared. So x squared. So u squared becomes x squared and then squared. And of course, that's going to be x raised to the power of 4. And put 2x on the top. And we're finished. We're finished. Okay. The next example I like to go over is going to be g of x equals to arc cosine square root of x. Okay. By the way, I can bring back the derivative of arc sine, arc cosine together with us. Okay, so for our reference, I'm sure you can find these in your flashcard. Okay, but I'm going to just bring them over, and arc cosine is negative. Okay, so arc cosine. So I'm going to bring that over. That's going to be arc cosine. And here we go, for our convenience. For our convenience, and arctangent. Arctangent is right here. And we're bringing it over here. All right. If we need more, we just derive them. All right. So now we're going to take a derivative of arc cosine of square root of x, right? the derivative with respect to x on g of x, that's going to be the derivative with respect to x on arc cosine square root of x. If we assume that arc cosine of x is arc cosine of u, right? Then du dx, and u is square root of x dx. There we go. And the next step, and we know that the derivative of arc cosine is equal to 1 over, right? But this is for x, and we have u here. So the derivative is going to be 1 over square root of 1 minus u squared. Okay, so if this is x, this is x. If this is u, right, with respect to u, and that's going to be u squared. All right, the derivative of square root of x with respect to x, that's going to be 1 over 2 times the square root of x. So, and then we're going to substitute u by square root of x. So we have a negative, so 1 over square root, okay? 1 minus u is square root of x, so u squared is going to be x. Multiply 2 times 1 over square root of x. So now by this time, we got, I think we just got, there's not much to simplify. You may like to bring the 2 in the front, so it's a negative half, right? 1 over, you can put them under the same root, right? X times 1 minus x, and put them under the same square root. That's it. Okay, so that would do. Now the third example I'd like to go over, this one is going to be more interesting. Okay, and this one is y equals to arctangent. Arctangent. X minus square root of 1 plus x squared. Okay. All right. Let's work on this. We want to do dy dx. We want to find dy dx. And that equals to the derivative, right? We're going to write as arctangent u du. And obviously u is going to be this piece, right? And the derivative of u with respect to dx. So that's our u. That's our u. And to find the derivative of u, we're going to have to apply, the derivative of difference. And when we do the derivative of difference, we're going to use chain rule again. All right, so let's just a little bit like that. It makes it a little bit easier to read. And this part, we're going to have 1 over 1 plus u squared. Okay, 1 over 1 plus u squared. So we got u squared. Okay. I hope everybody is working with me with paper pencil. Now we're differentiating the difference, right? We're going to differentiating piece by piece. So derivative with respect to x. First, we're differentiating the x and subtracting the derivative of the square root of 1 plus x squared. And obviously the latter needs to use chain rule. And now we want to bring u into our picture. Okay, so this place, u needs to be substituted by what u is equal to. Of course, what u equals to is this entirety of this parentheses. So u will be replaced by it. Okay. And we will come back to it. So let's look at what's in the bracket. In the bracket, we got 1 subtracting chain rule. Okay, chain rule. So we're going to see it as derivative with respect to v. Okay, so square root of v. Okay, so the square root of v. And what is v? V, of course, is the derivative of 1 plus x squared inside the parentheses. Okay, so you can see that we sometimes use chain rule multiple times. Now, we leave this part here for now, and we look at the bracket, and inside the bracket, we have 1 minus the derivative of v with respect to v, and that's going to be 1 over 2 times derivative of square root of v, and v, of course, is 1 plus x squared. Okay, you could actually skip this part and go here directly. And the derivative of 1 plus x squared, that's going to be 2x. So I'm going to put 2x right here on top. Okay, so let's see what we got. Okay, let's see what we got. Simplify, so this is 1 times 2x, right? And this 2 and this 2 reduced. But we want to reduce a little bit. Right? So we're going to find common denominator inside the bracket. Inside the bracket, 1, if we use the common denominator inside the bracket, that's going to be the same numerator as the same denominator. And after this step, we are getting with the same denominator, right? With numerator subtracting the numerator. So this is going to be subtracting x. By this time, the bracket actually is no longer useful. We don't need it anymore. Can we reduce it a little bit more? In order to find that out, we're going to foil. We're going to foil this. Okay. We're going to foil this. We could have foiled it here, you know. We could have foiled it here. So we foiled it here. We're going to get x squared. Oops. Okay, x squared minus 2x multiply square root of 1 plus x squared plus square root of 1 plus x squared. That's going to be just 1 plus x squared. Okay. So when we organize this term, right, so we look at this piece, which is simplified form, is going to go here. What are we getting? Well, we get x squared. We have 1 plus 1, 2. So we have 2 plus x, 2 times x squared. Subtracting 2x, multiply the square root of 1 plus x squared. It seems that we can factor out the 2, right? We can factor out the 2. And this is very good practice with algebra. Okay, so we factored out the 2, right? So 2 is factored out, 2 is taken out, right? 2 is taken out, and 2 is outside. Is there any room to reduce it? I don't think so. I don't think so. I don't think these are not common factors. So that's it. We're finished. We're finished. Do we need to rationalize it? I think for now, this is sufficient. As a matter of fact, for a lot of those questions you guys work with, up to this point, okay, up to this point, let me write it down here, okay? Up to this point, multiply that this guy, I would consider this acceptable final answer for a question like that. Okay, but this is a good exercise for our algebra. Okay, so let's do another one. This one should not be too hard. And this one is a capital RT is equals to arc sine of 1 over t. Okay, and of course we're going to differentiate it with respect to t. So capital R of t. So derivative, that's going to be chain rule. Let's do this a little bit faster, okay? We're going to have a u, 1 over u, 1 over t is a u, so the derivative of arc sine is 1 over square root of 1 minus x squared. So that's going to be 1 over square root 1 minus 1 over t, oops, 1 over t squared. Okay, and then we differentiate 1 over t, and that's going to be negative 1 over t squared. We're almost done. We're almost done. Okay, one more step, just to, I don't know, maybe one more step, 2 more steps. So it's 1 denominator, so we're going to have square root, right? Square root, and the 1 over t squared is going to be 1 over t squared like that. Multiply 1 over t squared. We're going to bring the negative sign to the front. Bring the negative sign to the front. Actually, this can be considered the end of this question. If we really want to reduce it, okay, you could. Okay, so let me show you a couple more steps algebraically. So you may like to play to derive along my side. Okay, so that equals to, so we have a negative. So what we're going to do is that we're going to have a common denominator inside the bracket. So that's going to make the 1 is going to be t squared over t squared, right? So t squared over t squared minus 1 over t squared, 1 over t squared, right? And that have the same denominator, so it's t squared minus 1 after, you know, the numerator, subtracting the numerator. And then we multiply 1 over t squared, okay? You could stop here, right? You could stop there, so I'm putting a box there, but here we just want to continue to enhance our algebraic skill. And we have a complex fraction here. We have a complex fraction here. So what we can do is that we're going to separate the numerator with denominator taking square root. So we're going to take square root like this. Okay, of course, get rid of that and take square root of that. okay? And then complex fraction, so we're gonna multiply the square root of t squared. Boom, boom, right? And then what we will see is that this is gone, and that's what we have. 1 multiplied square root of t squared, and this is actually equals to the absolute value of t, okay? Can we drop the absolute value? The answer is no, unless we know the sign of t. Unless we know. I think this is the best we can do so far. If you'd like to change a way to write it, you could bring t squared in front of it. That's it. I think that's all. Now we have, I see 2 more that we're going to do. Okay, these are pretty much the even number of questions in your homework. Okay, so this one is interesting. This one we have y equals to arc cosine of arc sine of t. Look at that. We have 2 layers of arc trig functions. Okay, so dy dt, dy dt, and that's going to be derivative with respect to dt. And here we have arc cosine of arc sine equals to, okay, derivative of arc cosine. I'm going to call arc sine t with u, so du, and then du dt. U is arc sine t. Okay, u is arc sine t. There we go. So now we're going to apply the formula arc cosine. And here we have arc cosine u with respect to u, arc cosine x with respect to x, right? These 3 places are the same. So now x is changed to u. So we're going to have negative 1 over square root 1 subtracting u squared. Multiply arc sine of t. So that's going to be 1 over square root of 1 minus t squared. Now, in the last step, we're going to substitute u by its equal, which is arc sine t. That's it. Consider that done. Last but not least, okay, this one, y is equals to arctan square root of 1 minus x over 1 plus x. Okay. dy dx equals to, that's our u, right? So we're going to apply directly. 1 over 1 plus u, this is a u, squared. And then we're going to differentiate u. U is the square root of it, right? So we're differentiating the derivative of u. And that requires chain rule, right? That requires chain rule. But let's, we didn't introduce any intermediate variable explicitly, but I think we can get by. If you have any questions, ask me, okay? So 1 minus x over 1 plus x. So this part is done. Okay, of course, we need to reduce that complex fraction. We're going to come back. And over here, we're going to take a derivative of this radical of a quotient. So we're going to apply, imagine that was the square root of v, square root of v. So that's going to be 1 over 2 times square root of v. And that v is 1 minus x over 1 plus x. So then we're going to differentiate with respect to this quotient, right? And we could actually, well, let's start it on the next step. All right, differentiate this quotient, denominator squared, numerator, right? Derivative, multiply 1 plus x, subtracting, we keep 1 minus x, and differentiating 1 plus x prime. Okay, and you can go to this step directly because this is going to be what? -1, and this is going to be +1, right? And if you like to put that in the bracket, you could. Not quite, not necessary, not needed, but I put in a bracket anyway. So next step, we're going to reduce it. We're going to reduce it, okay? -1 plus x, so that's going to be -1 minus x, okay? -1 plus x, -1 plus x. So the bracket will be left with -2, -2. So now it's going to be -2 left here. You can change it to parentheses, remove the bracket. And this -2 and +2, the 2 and 2 are reduced, right? So let me I'm going to the next step. So this is going to be -1. And this is going to be taking away the 2. I'm going to put the negative sign in the front. Now, reducing this complex fraction, what do we do? Well, this is a very good algebraic practice, okay? So on this piece, okay, I'm treating it as a complex fraction, and I'm going to multiply 1 plus x multiply 1 plus x on top and bottom. Boom. On this one, I'm going to write it as 1 minus x divided by root of 1 plus x. Okay, writing it this way, treat it as a complex fraction. So I'm going to multiply root of 1 plus x on top and the bottom. Now, reduce it. Okay, so I'm going to copy and paste. And this is going to be just 1 plus x, right? Gone. And that piece is just 1 minus x left. Okay, and 1 multiply that, you can remove it. On this part, 1 times that, remove it. And these makes 1. Okay, that's a little cleaner, right? Next, that's what we got. Plus x minus x. So the whole of it down here is the 2. Okay, 1 plus x here, 1 plus x squared. So this 1 plus x, it becomes 1, take away one of the 1 plus x. 1 plus x, root 1 plus x. So these two will become that, right? So this becomes 1. Now, in the end, we have negative, negative 1 over, okay? These two multiply under the square root, right? And there's a 2 in front. And that's going to be 1 minus x multiply 1 plus x. If we FOIL what's under the square root, we are getting 1 minus x squared. And we can remove the parentheses inside. So that's done, finished. I think that's enough exercise for now. If you have any questions, please don't hesitate to reach out to me. Thank you for watching.